Okay. So this is CS1130. The formal title is Introduction to Computing. This is a generic course, no, that is required to all programs, no, all students of different programs of the Computer Studies Division of the Ateneo de Davao University. Most of you are freshmen, but I've seen some sophomores, no. So anyway, so this is a requirement to all computer studies students, no, regardless of what major you are taking, no. So it doesn't matter what major you belong, as long as you're freshman or sophomore, you have to take this up. Okay. This is an introductory course, no. This is used to introduce you to the different topics or the different subject areas that you will take later in your course, no, which means that this is a sneak preview of the courses that you will take up in the future, no. So it is, if you've downloaded our syllabus, it's like the sequence is very similar, no, to our contents in Daigler, no? So you will have history of computing, you will have introduction to hardware, no, like arithmetic, computer arithmetic. You will have binary computer arithmetic, and you will have Boolean algebra, which is logic gates, no, introduction to computer architecture. And then you will have structure of basic computer architecture, and then you will have software. We will also discuss HTML, web development, and programming in JavaScript. If we will have time, we'll take up a little databases. Okay, so this is a sneak preview of all the courses that you will take, especially major courses that you will take later in your course, no, in your later years, no? So you will have subjects related to this even you are in your third or fourth or second year of studies, no, in the computer studies division. Okay, any questions so far? No? So I was asked earlier, no, regarding the possibility of face-to-face classes. We had a meeting before, no, our faculty meeting. We were introduced to a certain type of a classroom which can accommodate a mix, no, of online and face-to-face attendance of students, no. It's a facility, no? It's a classroom, no, where participants can either join online or physically, no, be present. It has certain gadgets, no. It was mentioned to be that way, no. It will have certain gadgets. It will have several cameras, so that both, no, remote and face-to-face, physically present students can participate, no? As of the moment, there's no guideline as to how to use those facilities, no? I understand we have to reserve them. However, I understand you are charged, no, computer lab fees, right? Is that correct? So maybe in the future, no, if you need face-to-face classes, the blended learning facility provides for the face-to-face classes of laboratories subjects. There are other courses that are using that now, no? Like engineering, no? They are doing face-to-face laboratory sessions. But as of the moment, anyway, we have an assignment, right? We are assigned to a laboratory, right? AIS. So maybe in the near future, no, we are going to make use of this, because if you are charged laboratory, then you have the right to use the actual lab. Okay. So for the moment, we will use you have to use your own computer. 4-101, right? Is that 4-101? Yes. So we are assigned laboratory on Fridays from online pa rin, no? I was wondering about this, no? Because the other students are assigned, no? The 3:05 to 5:05 on Fridays is reserved for lab, no? In other students, no, in my other classes, we are assigned a laboratory. It's not labeled online. Let me check. Oh, so meron silang F605, no? On Fridays. Friday is the day for laboratory schedule, no? Okay, so yeah, F613. That's a laboratory, no? So other students are given. I was wondering why you are not. No? I'll have to double check that. No? Maybe there's a mistake somewhere, no? Because you're supposed to have laboratory. So make sure, no? You can check if you have a laboratory, no? Laboratory fees, your charge laboratory fees. You can do that by checking the account balance link in your uh, SIS website. Have you checked your SIS already, everyone? Chat me if you haven't. Okay.
Yes, sir.
And all of you have checked your Daigler, no? So you all have no correct email, no? Because you cannot attend if you do not have correct email. Okay. Okay. Let's go back to our So this is our Daigler site. Okay. If you have no questions, we will proceed right away with our main topics. Okay. Okay. So this is introduction to computing. No? One of the most important aspects when we're trying to learn computing is to determine the design of computer architectures or computers that we are using, right? You have to understand what computers are, how they function, okay? Diba? It's normal. However, at this stage, no, computing technology has become so complex. It's not easy to study them. You can just start by asking someone or the students, describe the structure of the modern CPU, like the Intel Core i7 or the Intel Core i3. Describe the architecture. Can you do that? It will take you a long time, no? Maybe more than a month to put it all together, no? To describe the architecture of a modern computer. Why is that? It's because it's very complicated. No? It's just like being asked, how do you describe the modern organization of an automobile? Automobiles nowadays are computerized, no? Nowadays. So it's not easy. You'll have to take longer. You have to ask for, or maybe ask for more time, right? Now the problem with is how do we go about learning computing? Now, one approach is to study its evolution, di ba? Instead of studying the complex structure of an automotive engine, one approach is to study the evolution of automobiles. Okay, so study automotive industry, no? How they came to be, starting from the simple wheel to the combustion engines, no? Okay, to the transfer of and so on and so forth. No? That's how we go about it. No? We study how a technology evolved because in all types of technology, no, everything started in simple form, no. Wala namang, there's no technology that started complicated right away, no. Even computers, they started in simple forms. So one way to study computing is to study its evolution, okay, or study the history. Okay? So you may ask, when did this computing technology really start? Okay, who are the persons involved? Who were the inventors? Or you may ask, who invented the first computer? Anyone? Can you tell me? Can anyone tell me? Who's the inventor of the first computer?
Babbage lagi.
Charles Babbage.
Oh, Charles Babbage.
Charles Babbage, sir.
Okay, Charles
Yes,
Babbage.
sir.
What did he invent?
Analytical engine, sir.
Can you describe the structure of the analytical engine? Hindi pa pwede. Of course, no?
Yes, sir.
Hindi muna. Okay? So, but anyway, we'll go into that. Okay? It's not difficult to understand because the analytical engine is a very simple computer. No? Do you follow? It's a very simple computer. But in ancient times, the main method, the main facility or the main tool that is used to compute is what? Anyone? What's the oldest computing tool?
Abacus, sir.
Come again?
Abacus.
Abacus. Okay, can you tell me how to use the abacus? Ay, hindi na importante yan, di ba? It's not important. But anyway, it does it by the set, no? Set systems. You have a set of ones, set of tens, sets of hundreds, and then you have a beads that you can separate from left to right, so that you can count the total. No? The abacus is used to sum numbers, compute the sum and difference of two numbers, okay, in decimal. So there's a lot of YouTube videos that you can watch on how to use the abacus. Okay, so in the ancient times, the oldest tool was the abacus from China. Okay, but the history of computing can be traced back during the early modern period. Well, how is it? Why is it called modern period? This is the 17th century, 1642 to 1644. Okay, why is it called the modern period? Kasi Bronze Age, Iron Age, and then there's the age of the Roman Empire. For 1,000 years, the Roman Empire ruled the world, and then after that, there's the medieval Dark Ages. Because technology flourished a lot during the Roman times. Sa panahon ng mga Romans, technology in engineering, mechanical, agricultural, civil engineering, the Romans invented everything. Okay? Technology was so popular during the Roman times. Okay, math was very prevalent. The best mathematicians came from Rome, from the Greeks and the Romans. Galing doon. But when the Roman Empire fell, okay, when did it fall? 1100. Okay, technology stopped developing. Not much was invented after the fall of the Roman Empire. Okay, you follow? Europe, which was the most populated continent during that time, went into dark ages. Okay, ang ibig sabihin niyan, the countries there just keep on fighting with each other. They didn't invent anything. Walang invention, unlike during the Roman times. After the Dark Ages, the early modern period, what came the early modern period where mathematicians and inventors became popular. The earliest inventions after the abacus can be traced to France, in 1642 to 1644 by a scientist and an inventor called Blaise Pascal, mathematician, Blaise Pascal from France. All the development of computing technology started from Europe. Do you follow? But during the advanced period, all the modern developments transferred to the Americas, to the US. It started from Europe but flourished in the US. Okay? That's the trend. Nowadays, everything, the US is the primary source of computing technology. France, Blaise Pascal invented machines called Pascalines. So Pascalines, these are it's like the predecessor of an adding machine. When you look at that pictures, wala na akong ginawang name, but this is how a Pascaline works. It can do both subtraction and addition. Rotating wheels, where each wheel stands for a digit in decimal, and it can stand for 10 different symbols, 0 to 9. You increase quantity by rotating the wheel clockwise, and you diminish quantity by rotating a wheel counterclockwise. The first wheel stands for the ones, the second for the tens, hundreds, and so on and so forth. Do you follow? It's like a decimal odometer in a gasoline station, where wheels rotate in order to increment or decrement. They rotate clockwise to increment and counterclockwise to decrement. They follow? Invented by Blaise Pascal, the simplest form. And then also about the same period from Germany, Gottfried von Leibniz invented the step reckoner. Okay, what's a step reckoner? It's an upgrade of the Pascaline. Ganyan talaga yun, from first generation to second generation. The technology upgrades. The first version was the abacus, the second version was the Pascaline. The third version is the step reckoner. If you look at the picture, the step reckoner is like the Pascaline. Okay, but it has a crank, a crank on the left. It's like an adding machine. The crank is like the enter key or the left click of the computer keyboard. When you say crank, you press enter. Do you follow? No? Type the first number, press enter. Type the second number, press enter. Okay. You follow? So there's a crank, no? Now, in addition to subtraction and addition, no, the step reckoner can do multiplication by a process called repeated addition. Okay, so it has rotating wheels also, no? It's like a binary odometer, rather decimal odometer. It's not binary, no? Okay, any questions so far? Gottfried von Leibniz, no? And then in the early 19th century, 1801, kasi kung 1600, that's 17th century. 1800, that's 19th century, okay? Because 00 is the first century, okay? An important invention in the field of recording came about, no? In France also, by Joseph Marie Jacquard. Kasi computing technology was developed in two fields, no? Computing mechanical computing and recording. Do you follow? When you say mechanical computing, the machines that are used. When you say recording, the machines that are used to record data. In modern days, we call them the memory. No? So the first form of memory that was invented was in 1801, invented from France, in France by Joseph Marie Jacquard. Kasi the only machine available for recording then was punch cards, no? Punch cards, wooden punch cards. Ibig sabihin, you punch a particular sequence of holes to represent a particular quantity. Okay? Do you follow? Ganon yun. To do that, Joseph Marie Jacquard used a machine for weaving fabric. Okay? It's called the Jacquard loom. Okay. Fabric weaving. Kasi ganito yun, no? A loom is a machine that is used to weave fabric from different raw materials, no? Now, the Jacquard loom is used to both read and write decimal numbers to punch cards, no? It started in wooden punch cards, no? But later cardboard na. What it does is, to write a value, it has to punch holes to a card. A particular sequence designates 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, no? They follow? And then in order to read the values from the card, a thread is used, okay? A set of threads. Ito, no? Where is that? No? Ito, mas klaro. Is used to go through the holes in the punch card. Okay? Depending on the sequence of the threads that came out along the process, no? A particular value is read. Do you follow? There is no actual example, no? Wala tayong actual example dyan, but that's the technology, no? In order to save data, because it's a recording device, a certain quantity corresponds to a unique sequence of holes on the card. To read it, no? A set of looms, fabric, no, are used to pass through the codes, or rather the holes, such that depending on what comes out, a value is read, no? The corresponding value is read. Okay? Any questions? No? So simple design. Holes and threads used to read and write data. And then also about the same period, Thomas de Colmar invented the arithmeter. The arithmeter is like an upgrade of the step reckoner. No? Kasi ang step reckoner hanggang until multiplication. Okay? It's like the same, no? So it also has a crank on the left. No? Why do they put the crank on the left? Because you use the right hand to type the keyboard. Okay? When you crank, you say enter. You're like pressing the enter key. Okay, the arithmeter can now perform division. It's the first machine that can perform division. It was commercially produced, no, as mechanical calculators, no. Do you follow? No, arithmeter. So a modern adding machine looks like this. Ganito na yung ito electronic na ito. This is a manual adding machine. Have you seen this? This is a right-handed adding machine, no? Look at the crank, it's on the right side. If you have something like this, you should keep it because it's a treasure. No? It's a treasure. If you have this, it's an antique, no? Even something like this, no? Can still like this, no? That's considered a treasure. But this one's very old, no? With that, no? If you have something like this, that's the original wooden adding machine. But you can see this in a Chinese restaurant, okay? When you order food, no? And then they type your there, no? Because most Chinese use old Chinese, no? Either use abacus or and the old adding machines. And they ring every time you press and you press, ping, it makes a ring to tell the user that the result is ready. If there's no ring, then you have to type it again. Okay. Any questions? No. So that's the arithmeter. Now, during the modern period, it's the 19th century, 1822. This is where most of the development. Imagine, no? The first computer came about in 1822, early 19th century, in Great Britain. Look at that, no? All the technologies came from France, Germany, Great Britain. Walang Russia, no? Wala pa masyadong Russia. Basta galing yan sa France, Germany, and Great Britain from Europe, no? Okay. In the early 19th century, no? Charles Babbage, who was a mathematician at Cambridge, no? Cambridge University was already there, no? Invented a certain type of a machine called differential engine, no? So differential engine, where is that? The differential engine is actually an engine used to tabulate and compute polynomials. Okay, polynomials. So, no? This is a difference engine to tabulate and compute polynomials. Okay. So basically, no, decimal numbers are used, no, and then the rotating gears are there to represent symbols. They rotate clockwise to increment, rotate counterclockwise to decrement. Okay. But the more significant invention by Charles Babbage was the analytical engine, which was considered to be the first computer. Why is that? In a calculator is not a computer, no? It only uses constant values like decimals, no? Numbers. A computer uses two sets of inputs, no? The set of numbers and a set of instructions, no? So merong program and parameters. Do you follow? And a computer is programmable. It can run different applications, not just like fixed addition, subtraction, division, multiplication. No, no. In fact, no, somebody was able to demonstrate that the analytical engine can be used for various mathematical processes. No? Okay. The invention by Charles Babbage was called the analytical engine. Okay, we will study this, no, closely, no. Why? Because it will help us understand the modern architecture, no. Really. Here it is, no. This is the unfinished version, no. This is the simpler version because the original machine can compute 40 digit, no, computations. This is a simpler form developed by Charles Babbage to perform 20 digit computations, no. So 20 rotating gears, no. Can we have that in closer, no? Bakit walang mas malaki? Pwede pa palakihin. Ito, no? So 20 rotating gears on the side, no? 20 ito. The original design was 40 bits, or rather 40 digits. Ito. If you're asked to program a computer like this, you should be very careful, no? You could easily cut a finger by a mistake. These are sharp gears, no? If you program a computer like this. Now you may ask, was there a program running on that computer? Anyone? What programs are used to write or to run on the analytical engine? if it was a computer. Fortunately, now very few people use that for programming. No? In fact, people, the scientific community, even there already engineering is already established. No, meron ng mga engineers, there were trains, no, industrial industries have developed. No? The scientific community during those times are not interested in Babbage invention because they could not understand how it works. Fortunately, one mathematician, also from Great Britain, also from Cambridge University, do you follow? Recognize the work and tell the people in actual symposia and forums, no, during that time, that the invention of Charles Babbage is very important because it can be used to solve real life mathematical problems. No? The person who recognized it was the Countess of Lovelace. No? Lovelace is a certain area in the Great Britain. No? Augusta Ada King, Countess of Lovelace. No? These are royal blood. No? And she produced programs, no, to run on the machine. Tingnan natin, no? Programs on the analytical end. We have material on this, no? Inimpute niya ito using Bernoulli numbers. No? An application on Bernoulli numbers. Bakit wala, no? Application, compute the nth Bernoulli number, no? Given n, what's the next number in the series? No? Ang hirap, it's not an easy, no, program to use. There's a documentation on how the program looks like. Okay, do you follow? So Countess Ada Lovelace demonstrated how the invention of Charles Babbage can be used to solve real-life problems. Okay, he showed algorithms. During those times, no, they were called algorithms. Nowadays, they're also called algorithms. No? Okay, to be carried out on such a machine, which means these are programs, no, such that Countess Ada Lovelace is known today, no, as the very first computer programmer. Do you follow? No, ang pinakaunang computer programmer is Countess Ada Lovelace, Augusta King of the Great Britain. She died very early, no, at age 41. She was a binary arithmetician and one of the leading mathematicians during her time. No? Mathematicians from Cambridge. Okay. At the same time, no, during the late 19th century, no, a certain invention in the USA this time, no, was developed by Hermann Hollerith. Hermann Hollerith. Who is Hermann Hollerith? Anyone? Hermann Hollerith is the first. What did he know? He is the first president of IBM. No? Siya ang nag-establish ng IBM, which became the IBM PC. Okay? Hermann Hollerith was an American inventor and businessman. Produced punch card tabulating machines, no, as an improvement of the Jacquard loom. No, this time it doesn't use weaving machines, no, to record and read data. No? These are the this is the Hollerith punch card, no. So it is an 80-column card where one column can be used to designate a digit, no. So ones, tens, and so on and so forth. No? This is the Hollerith machine, no, which is used to record and read data from a given punch card. No? Actually, this was used to tabulate U.S. census during that time, no, because during that time, no, population count can take 10 years. No? In order to facilitate the count, Hermann Hollerith developed a recording machine called the punch card. No? It's not electronic, no? It's still a mechanical punch card tabulating machine. he patented it in 1884 and began, no? So it was like the first hard disk. Punch cards was the most popular media for recording, okay? Any questions so far? Ay, naubos na yung oras natin. I'm sorry, no, we ran out of time. Am I correct? Yes. You spelled over. I'm sorry, no? Anyway, we'll continue with this next meeting. Anyone else I haven't checked? Okay. So our next meeting is on Monday. Monday, no? Our next meeting is on Monday, July 25. Ito yung ano, di ba? I don't think this is a holiday in Davao City. This is the State of the Nation address of the next president. I don't think it will be a holiday here. But anyway, we'll just meet, no? Any questions? I'm sorry I went over time, no? I didn't recognize it. Any
Friday,
questions?
sir, wala.
Sa Friday, wala tayong Friday because Friday will be our lab time, okay? We will do synchronous lectures on Mondays and Wednesdays. Okay?
Do we have to go to school?
Sa Friday, hindi pa, no? Hindi pa pwede. Okay? But you wait for that, no? Kasi the school may open. But I think, no? At most, face-to-face classes will be done during lab schedule, okay? If it's possible, no? Lectures will be online. Okay? But I think, no, if face-to-face classes are done, it will be during laboratory time. Okay? Any other questions? Now, if you have questions, no, which you could not ask, you can post them in our forum. Na dito, no? Okay? I will upload the recording like this, no? There's a Zoom meeting which I had earlier. And you can click on this and it will redirect you to a YouTube site where I will save my lecture recordings, okay? So, see you then, no? See you on Monday. Everyone, thanks for coming.
Thank you, sir.
Okay, thank you.
Thank you, sir.
Bye, sir. Thank you.
Bye, sir.
Thank you,
Thank
sir.
you.
I love you, sir.
Thank you.
Thank you, sir.
Thank
Thank
you.
you, sir.
Thank you, sir.